So our first type of problem involving resolving vectors into components is when we are talking about pulling little red wagons. Newton's second law says that the net force acting on an object will cause it to accelerate, specifically in the direction of the net force. If we want something to move east, we should exert our force to the east. If we want something to move horizontally, we should exert our force horizontally. If we exert our force at some angle to the horizontal, we have wasted some of our effort. Three boys are going to have a race with their little red wagons. Each has a mass of 12 kilograms. They exert a force of 40 newtons on the handle of the wagon, but at different angles. Who wins the race? And hint, that means calculate the acceleration. So in this one, we are going to operate on the premise that the coefficient of friction is 0. So we are ignoring friction in this exercise. So we have a picture for each scenario. So we'll look at the one on the left. So we have a wagon that is mass 12 kilograms, and the boy is exerting a force of 40 newtons, and this one is to the horizontal. So the acceleration that we're looking for is in the horizontal. This entire force is horizontal. So looking at Newton's second law, the acceleration is the net force divided by the mass. Our net force here is 40 newtons and the mass 12 kilograms, and so we find an acceleration of 3.33 meters per second squared. The second little boy is also pulling a wagon of mass 12 kilograms. He is also exerting a force of 40 newtons. However, this time, this little boy is pulling at an angle of 20 degrees to the horizontal. So let's go ahead and extend that out. And so you have to look at the components here. So we have the horizontal component, and we have the vertical component. So if we were to make this a triangle, it would be a right triangle. So we're talking about horizontal and vertical components. Really, we're only concerned with the horizontal. He is trying to accelerate this wagon horizontally, which means only the horizontal force is accelerating the wagon. So we are looking for the horizontal force. So the horizontal force, so here's the angle, and we are looking at an adjacent side and a hypotenuse. So this tells us, adjacent and hypotenuse, that we're going to use cosine. Cosine of 20 degrees equals the adjacent, which is the horizontal force, over the hypotenuse, which is 40 newtons. The force in the x direction is 40 cosine of 20 degrees. And so we find that the horizontal component of the force is 37.59 newtons. For the acceleration, it is the net force divided by the mass. The net force in this case is the horizontal component of the force, 37.29 newtons, divided by the mass, which is 12 kilograms. So the acceleration here is 3.13 meters per second. And let's look at the third little boy. The third little boy is exerting a force of 40 newtons on the handle. In this situation, he is pulling at an angle of 50 degrees from the horizontal. So we resolve its components. Here is the horizontal component of the force. Here is the vertical component of the force. So here's our parallelogram, and it actually forms two right triangles. And we want to know what is the horizontal component of the force. Again, it's going to work the same as last time. So we have an angle with an adjacent side and a hypotenuse. So this time it's cosine of 50 degrees equals the horizontal component of the force divided by 40 newtons. Solve for Fx. This will be your minimum step of showing your work. And we find it is 25.71 newtons. So calculating the acceleration, the net force is the horizontal component, 25.71 newtons, wagon mass 12 kilograms, and we find that the acceleration here is 2.14 meters per second squared. So who wins the race? It would be the little boy who was able to accelerate his wagon the fastest. 3.33 is the fastest acceleration because all of this little boy's force is going in the horizontal direction. Second place is the one with the smaller angle. And third place is the one who is exerting more of his force vertically than horizontally. The bottom line, only the force in the direction of motion counts. The next problem is one of my favorites. Hint, hint. Means you'll see one on the test. More than one, maybe. To see if students understand friction as well as resolving forces. Compare these three situations by finding the acceleration of the box, which is mass 8 kilograms, as a force of 24 newtons is exerted on each. So in part A, we have a box. It is 8 kilograms in mass. The coefficient of friction is 0, which means this is a frictionless environment. A force of 24 newtons is applied horizontally. And so we're looking for the acceleration. This is the same type as the Little Red Wagon. We're looking for the acceleration because we want to know which one's the fastest, which one wins. So using Newton's second law, the acceleration is the net force divided by the mass. The net force is the horizontal component, and that's all of it, 24 newtons. And there's no friction, so we can leave that part out of it. All of the force of this pull is useful force, the whole thing. And the mass is 8 kilograms. So the acceleration is 3 meters per second squared. Part B, again, we are applying the force horizontally. So here's my 24 newtons on my 8 kilogram box. But this time, we have a coefficient of friction. Remember, the coefficient of friction is really the stickiness factor. So in order to figure out the net force, we have to figure out the force of friction, because there is some amount of friction holding us back, but we don't yet know what it is. But we know the formula: the coefficient of friction equals the force of friction divided by the normal force. We know the coefficient of friction, and we can find the normal force. So let's solve for the force of friction, and it is the coefficient of friction times the normal force. Coefficient of friction in this case, 0.20. Remember, the coefficient of friction has no units. Then we have the normal force, which on a horizontal surface like this one is equal to the weight of this object. So the weight is its mass times its acceleration, which is 10 for gravity. And so we find the force of friction is 16 newtons. So to calculate the acceleration, we have the net force divided by the mass. The net force is our pull, 24 newtons, minus the friction that's holding us back. And then the mass is 8 kilograms. And so the acceleration of this box, just due to friction, is 1 meter per second squared. Now, the one with the force that was entirely horizontal and had absolutely no friction, it's going to get first place. The only question is now, who comes in second place? Is it this one, or is it this one? In part C, we have a force that is applied at a 30-degree angle, meaning 30 degrees to the horizontal. 24 newtons, and that's 30 degrees to the horizontal. So we have a horizontal component, we have a vertical component, and the box is mass 8 kilograms. When you resolve vectors, it will make a right triangle, and we are looking for the horizontal component. The horizontal component, so we have an adjacent side, and we have a hypotenuse. That tells me 24 times the cosine of 30 degrees. And so when I calculate acceleration, this is my net force because there's no friction. So all of the force in the horizontal direction is the net force. So you could solve this and put the number down here, or a quick shortcut, 24 cosine of 30, and that's newtons, divided by 8 kilograms of the mass. And the acceleration in this one is 2.60 meters per second squared. Who gets second place? The angle with no friction gets second, and the horizontal with a 0.2 friction